All right, welcome back to another video on antiderivatives. Let's deal with exponents now that are fractions. Remember, rational means fraction. Let's take a look at our first example, which is a square root. Well, what is a square root? A square root can be represented as a power of 1/2. And there you go, an exponent that is a fraction. Well, I guess we need to add 1 to get that antiderivative. So half plus 1 is 3/2. A cheap thing you can do is just add 1 and 2 together to get 3. In this case, we're going to do x to the 3/2. According to the power rule, we would divide by that same quantity, 3/2. When you divide by 3/2, it is equivalent to multiplying by 2/3. We're done the question, but just a quick comment as I'm trying to write a 3 there. Okay, this is looking really funny. This looks like a checkerboard. See the 2 and the 3 and the 3 and the 2? Looks like a checkerboard. We're going to use this pattern often when dealing with rational exponents. In this next example, we have the cube root of x, which we can quickly write as x to the 1/3. When you add 1 to 1/3, you get 4/3. A cheap thing you can do here is just add the bottom to the top to get the new numerator. Here we go, x to the 4/3. As I mentioned earlier, when you divide by 4/3, it's the same as multiplying by 3/4. And you can do that in less writing as I've done there. Again, there is that checkerboard pattern that I referred to in the previous example. 2 more examples to go. In this next example, we have a coefficient. As far as you're concerned, that coefficient, the 10, is just a spectator. So just leave it on the side and deal with it later. In this case, if we take a quarter and add 1, we get, well, 4 plus 1 is 5. That's my little shortcut. We get 5/4. So this is 10 times x to the 5/4 divided by 5/4. Or using my pattern of the checkerboard, you can just do that and add c. Now, 10 times 4 is 40 divided by 5 is 8. So that becomes 8x to the 5/4. Don't forget your constant. Last example, why don't we kind of synthesize something using the previous video, which involved negative exponents, and also a rational power. Now, this could be written as a cube root to the power of 4, but it's all good. Let's take the 7/5 and just pull it aside here and deal with the exponent. In power form, we would have x to the negative 4/3. What is negative 4/3 plus 1? Well, you just add the bottom to the top, and you get negative 1/3. And there you go. We have 7/5. X to the negative 1/3. Let's use the checkerboard pattern. So that'd be negative 3/1. Now I flipped it as well, and I included the negative. Don't worry about where the negative goes, because it's in front of the fraction. When you take the reciprocal of a negative number, it's still negative. We can simplify all of these numbers here by multiplying 7 times negative 3. I'll just write it on the side here. That's negative 21, and you divide by 5. But we have this negative exponent here as well. That just means we bring it down to the denominator, so we'll have 5x to the 1/3. I'm trying to squeeze it in there, make it look a little pretty, and there you go. That is the answer. Don't forget your constant. Look at that. I almost made a mistake. And I'm going to leave it like that because I want you to remember that even the smartest people make silly mistakes, and it's always good to be on your toes. Thank you very much.